Okay, welcome to all students. Now in this lecture we draw the graph of given graph for the given linear programming problem. Uh, in the previous lecture we have drawn we have seen that how to find 2 points on the straight line. We have to draw straight line on that graph and we find out the feasible region for the given linear programming problem. So for that we draw two lines. So our first line is our first line is 5x plus 3y is equal to 4x plus 6y is equal to 24 is our first line, and the 2 points on that first line are 0 comma 4 and 6 comma 0. So first of all we put a scale on that line. So here it is 1 2 3 4 5 and 6. So scale on the x-axis. Similarly put a scale on the y-axis. Here it is 0 origin, uh, 1 2 3 4 5 and 6. So this is the scale on y-axis. Now we plot 2 points on that xy coordinate system. So our first point is a 0 comma 4. The position of that point on this coordinate system is here 0 comma 4. Sorry, this is 4 comma 0. So 0 comma 4 is here. So this is our first point. Okay, so we plot this point a 0 comma 4. Now the second point is 6 comma 0 and the position of that point is here b point 6 comma 0, and we join these 2 points by using straight line. So let us take a straight line and join these 2 points. Okay, so this is the line corresponding to first inequality, and the region corresponding to this first inequality is towards origin side because it is less than or equal to type inequality. So now we plot the 2 points on the next line, and our next line is 5x plus 3y is equal to 15. So this is our next line. So first point on that line is 0 comma 5. So where is the position of that point 0 comma 5? It is on the y-axis 0 comma 5. Okay, 0 comma 5 is here, so we call it is point C, 0 comma 5, and the second point, D point is 3 comma 0, and that position is at here. That point is called as point D. Three comma 0. Okay. Okay, so this point is D point, just we write here D. T point. Okay, now again we join these 2 points by using a straight line. Okay, and now region corresponding to this line, this inequality is also towards origin side, so we identify the regions. Okay, so we go to find the regions of each inequality. Our first inequality is to find regions. We write here to find regions corresponding to regions of inequality. So our first inequality is for x plus 6y less equal 24, and in this inequality if I put the values of coordinates origin, values of put x equal to 0 and y equal to 0, means we check whether origin satisfies given inequality or not. So if I put x equal to 0, then 4x plus put y equal to 0, 6 into 0 is equal less than or equal to 24, and this left hand side becomes 0. This is less than or equal to 24, and this is true. 0 is less than or equal to 24. Therefore, the region corresponding to this inequality is towards origin side. The region corresponding to this inequality is towards origin side. Therefore, in the graph paper, this is our first inequality and its region is towards origin side. So just draw one arrow towards origin side. Now for the second inequality, we identify the region, and our second inequality is 5x plus 3y is equal to 50, is less equal 15. Okay, 5x plus 3y is less equal 15. So we identify the region for second inequality. It is 5x plus 3y. Okay, 5x plus 3y is less equal 15. Put the coordinates, values of coordinates of origin 0, 0 in it, means put x equal to 0 and y equal to 0. 5 0 plus 3 0 is less equal 15, and this left hand side value is 0 and less equal 15, and it is true, 0 is less equal 15 is true thing. Therefore origin satisfies this inequality. Therefore the region corresponding to this inequality is again towards origin side. Therefore region is towards origin side. Okay, so in the graph paper we mention this region is towards origin side. Okay, also we write the region of these two inequalities. X greater equal 0, y greater equal 0, region is first quadrant.
We have used up to 2.56
Region is first quadrant. Okay, so in this case we have three regions, and out of these three regions we have to identify the common region. So common region is, this is our first quadrant, whole quadrant is the first quadrant, and the common region is this. We shade this common region now by using okay, the common region is this green region. Okay, that region is called as feasible region, means our solution is in this region. So every point in this region is a solution, but we have to find out the optimum solution for the given linear programming problem. Okay, so this is our feasible region. So in this region, so every point in that region is a solution, but we have to find out optimum solution. We give the name to this region as a feasible region. Okay, and the optimum solution always appears at the corner of feasible region. So we point out the corners of this region, or we denote these corners. So this is our first quadrant, whose coordinates are origin. Next corner is D. Next corner is point A point, and this corner is, we give to the name to this quadrant Z, and we have to find out the coordinates of that corner. Okay, now in this way we have first corner. Okay, so we write here, we write in diagram above diagram green region is feasible region. Feasible means possible solutions, feasible region. Okay, optimum solution appears, optimum means maximum or minimum. So optimum solution appears at corner of feasible region. Okay, F formula, feasible region. Okay, so what are the corners? Now we find out corners of feasible region. So first corner is origin O 0, 0. Now what is next corner? Second corner is A point, point A, point A whose coordinates are 0, 4. 0, 4. Now next corner is origin A Z, which we have to find out, and next is D. D point has coordinates 3, 0. Z corner we have to find out, and D has coordinate 3, 0. Okay, and here, so D point, where is D point? 3, 0. Okay, so here is D 3, 0. Now to find out coordinates of point Z, next we find Z, but point Z is the intersection of two lines. It is intersection of two lines, so we write these two lines and solve these two lines. So for our first line is First line is 4x plus 6y equal to 24. Here is our first line, 4x plus 6y equal to 24. Four x plus 6y is equal to 24, and second line is 5x plus 3y is equal to 15. So now in the 10th standard you have studied how to solve two equations in two line. Okay, so this is our first equation, This is our second equation. So to solve these two equations, we multiply to second equation by 2. So 2 into equation second, then we get 10x plus 6y is equal to 30. We call it is equation number 3. Okay, and then we subtract first equation, we subtract this third equation from equation 1. So you will get the subtraction 4x plus 6y is equal to 24, and the third equation is 10x plus 6y is equal to 30, and we take a subtraction, so sign of the terms will get changed. So in this subtraction, minus 10 plus 4x, minus 10 plus 4 is minus 6x, and here it is 0, minus 6y plus 6y is 0, and on the right hand side we get 6, minus 6. Okay, so minus 6x equal to minus 6 means x is equal to 1. So we found the first coordinate of point Z. Now put x equal to 1 in above equation 1. Put in 1. So you will get, if I put x equal to 1 in equation 1, then equation 1 becomes and that equation 1 is 4 into 1 plus 6 into y is equal to 24. Okay, that is 6y is equal to 24 minus 4, and therefore 6y is equal to 20, and therefore y is equal to 20 upon 6, that is y equal to 10 by 3. Okay, 10 by 3. So thus we have the coordinates of corner Z. Coordinates of corner Z. First coordinate is 1, comma 10 by 3. So in this way we have all the corners of feasible region. Now we know that the optimum solution appears at the corner of the feasible region. We find the value of objective function at each corner. So our next step is find out value of objective function at each corner. Find value of objective function at each corner. Okay, so let us take first corner. First corner is origin. Okay, first corner is origin, so we write here first corner is origin O 0, 0. Our objective function is P is equal to p is equal to 150 into x plus 75 into y. So here put x equal to 0, y equal to 0, and therefore p is equal to 150 into 0 plus 75 into 0 and is equal to 0. So at first point, at first corner, the value of objective function is 0. Okay, now we find the value of objective function to the second coordinate, to the second corner. So our second corner is point A, and whose coordinates are 0, 4. So and our objective function p is equal to 150x plus 75 into y. So in this objective function, put x equal to 0 and y equal to 4, y equal to 4. So our value of objective function is 150 into 0 plus 75 into y is 4. So value of p is equal to 300. So value of objective function at this point is 300. At first point the value of objective function is 0. At this point of value of objective function is 300. Now at the third coordinate, at the third corner, our third corner is corner z, and whose coordinates are 1, 10 by 3. Okay, and the objective function is p is equal to 150x plus 75y. So in this objective function, put x equal to 1, y equal to 10 by 3, and therefore we have p is equal to 150 into 1 plus 75 into 10 by 3. So it is 150 plus, it will be 25. Okay, so 25 into 10 is 250, and so finally we have it is equal to 400. So value of p at this point is 400. Okay, now our last corner is D corner, fourth corner D, and whose coordinates are 3, 0. Objective function p is equal to 150x plus 75y, and at this objective function put x equal to 3 and y equal to 0. So p will be 150 into 3 plus 75 into 0, and therefore p is equal to 450 plus 0. So p is equal to 450. Okay, so the maximum value of the objective function appears at the point, the maximum value of the objective function is 400. 400 and it appears at the point Z. It appears at the point Z. Okay, so Z has value 1 comma 10 by 3. Therefore maximum value of objective function is, we are finding a maximum value because we have to maximize the profit. P is the profit function. Maximum value of the objective function is 1 minute 450 and it appears at the point, occurs at point D point whose coordinates are 3 comma 0. Therefore the solution of our LPP, therefore solution of LPP is, solution of LPP is, okay, solution of LPP is x equal to 3 and y equal to 0. Okay, so this is the end of this problem. And end of the lecture. Thank you. Okay, we stop here.